Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graphs. So let us see our today's question. Our today's question says, is graph bipartite? What do we mean by a bipartite graph? Let us understand in this particular question. In this question, we are given an undirected graph with n nodes where each node is numbered from 0 to n minus 1. We are also given a 2D array graph where graph at the index of u is an array of nodes that node u is adjacent to. Means this array graph is telling us the nature of the graph with which edges that particular node is connected with. And the graph is undirected. The properties of this question is there are no self edges. That is, graph at the index of u does not contain at the u. It means there is no edge which is connecting to itself. There are no parallel edges. Graph at the index of u does not contain duplicate values. If v is in graph at the index of u, then u is in graph at the index of v. That is, the graph is undirected in nature. And the graph may or may not be connected. It means there can be more than one component in this particular graph. Now, when is the graph called as bipartite? A graph is referred to as bipartite if the nodes can be partitioned into two independent sets A and B, such that every edge in the graph connects a node in set A and a node in set B. Then the graph is referred to as a bipartite graph. We need to return true if it is bipartite, otherwise we will return false. It means it's a Boolean value function. So let us understand this question with the help of an example. We were given a graph which contains nodes 0, 1, 2, and 3. We were given a 2D vector graph. Now, what does that mean? At index 0, 1, 2, 3 is there. It means there is an edge from 0 to 1, 0 to 2, 0 to 3. 1, 2, 3 is presented at index 0. 0 and 2 is present at index number 1. It means there is an edge from 1 to 0 and there is an edge from 1 to 2. I hope you are understanding how we have formed this particular graph. At index number 2, there is a value 0, 1, and 3. It means from 2, there is an edge from 0 to 1 as well as to 3. And at index 3, there is a values are 0 and 2. It means the edges are from 3s to from 0 and towards 2. So in this way, we have formed this particular graph. Now the question arises, is the graph bipartite or not? For a bipartite graph, we need to partition it into two independent sets A and B such that every edge in the graph connects a node in set A and a node in set B. In simple terms, we can understand a bipartite graph in such a way that we have to color the nodes such that two adjacent nodes should be colored with opposite colors. If we are coloring 0 with a blue, then we have to color 1 with a red. So if we have color 1 with a red, so now we have to color 2 with a blue. But since 0 is also colored blue, so these two adjacent nodes will be colored with the same color. There is no chance. So in this case, this graph is a non-bipartite graph. So we will return false. Bipartite graph means if it is possible to color all the nodes such that two adjacent nodes should have different colors, then it is a bipartite graph. Otherwise, the graph is not bipartite. In example number 2, 0, 1, 2, 3, we can easily color it with two different colors. If we color 0 with blue, 1 with red, 2 with blue, 3 with red, then in this case, no two adjacent nodes have same color. So it means it is possible that this graph is bipartite. So we will return true. So I hope it is clear to you all how we are going to identify whether a graph is bipartite or not. So now let us understand this particular question with the help of the code. What we did, we were provided with a graph, vector graph. So the very first step is to prepare the adjacency list. What are the total number of nodes present in a graph? The indexing is zero-based indexing. It means the first node is starts from index 0 and the last node is of n minus 2. So the size of our adjacency list is going to be graph.size. So the number of vertices is going to be graph.size. Then for int I equal to 0 and less than graph.size I plus plus, you have formed the adjacency list from line number 30 to line number 39. What we did is we just at index number 0, we have pushed all the values at ATJ at the index of 0, dot pushback V1 at the index of J. What does the V1 vector contains? That particular vector which is at index 0. So I hope the formation of adjacency list is clear to you all. After that, we have defined a variable v for denoting the number of vertices in the graph, and we have initialized it with graph.size. Then we have defined a vector color, and initially we have assigned this vector color with -1 values. For int I equal to 0, I less than vi plus color at the index of I equals to -1. Then we have applied for int I equals to 0, I less than vi plus plus. If color at the index of I double equals to -1, it means it is not yet visited. Then we have called the check function. The check function is the main function which is helping us to identify whether the graph is bipartite or not. So let us see what we did in the check function. In check function, we have used the BFS traversal, breadth first search traversal. Now how we did it? First of all, we have defined a queue. In this queue, we have pushed the starting index which we have passed in our check, and we have defined its color as 0. Color at the index of start equal to 0. While not equal to q.empty, int node equals to q.front, q.pop. Then we have find the adjacency list connected to that particular node. This auto IT ADJ node is helping us to connect to all this particular node is connected to many edges, right? If its first neighbors. So this ADJ node will help us to iterate through its first neighbors. If its first neighbors is not yet visited, we will assign them the opposite color. That is, color at the index of IT equals to the opposite color that is not equal to color at the index of node. And we will push it. If it is already visited, then we will check, are the colors opposite or not. If the colors are not opposite, if the colors are same, it means the graph is not bipartite, and we will directly return false. And if false is returned, then we will directly return false in our main function also, in our is bipartite function also, because the graph is not bipartite. If false is not returned, we will return true. It means the graph is bipartite. I hope the question is clear to you all. The question was based on a bipartite graph. You just need to understand this. What is the meaning of bipartite? If you are able to figure it out, you can easily solve it using the BFS traversal. I hope the question is clear. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.